Uh, Hello everyone. Uh, welcome everyone. To SNEA India's webinar on empowering developers exploring LLM models for code generation. I'm heading marketing for SNEA India, industry association that develops global standards and delivers education on all technologies related to data. Uh, so I'm thrilled to announce, our distinguished speakers here. We've got with us Rajat Ghosh, staff data scientist at Nutanix, leading on Gen AI application development and Gen AI customer services. He joined Nutanix after he exited from his startup that he founded during his PhD at Georgia Tech. He holds a BTech from IIT Kharagpur, India. And we also have got with us Harshil Dadlani. He's a member of technical staff at Nutanix. He has experience in building NLP-based products for search and generative ML applications. Prior to joining Nutanix, he was a graduate researcher at University of Washington, Seattle, where he did his research in reducing the interference time for pre-trained LLMs. The third speaker we have, last but not the least, Mosumi Rana Singh. She's a staff engineer at Nutanix. She leads Gen AI application development and API infra for files in cloud. She has around 15 years of experience, and she has worked on various areas like API, UI, infra cloud, and Kubernetes. She holds a BTech degree. So I would like our speakers to go ahead. And Rajat, would you like to take over from here?
Yeah, sure. Thank you, Pratham. It's a slide. How to move the slide? Okay, great. Thank you.
Yeah.
Hello, everyone. Am I audible? I guess.
Yes, you're audible, Rajat.
Hello, everyone. This is Rajat Ghosh. I'll be talking about LLM based code generation. So LLM means basically large language model, and large language model has the power to unify different tasks. So when you talk about software engineering, it can do planning, designing, it can write code for you, it can do reviewing, it can write unit tests, and it can also do documentation. So overall, imagine it's like a software engineering factory which can do all sorts of tasks, and output will be a high quality software. And when you talk about this software engineering as a discipline, there are multiple tasks in it, like coding, debugging, testing, maintenance. And the key value essentially is produced during coding when you have some algorithms, some data, and you produce some kind of output. But the debugging, testing, and maintenance, all these activities nonetheless very critical to ensure that you are minimizing your tech debt. And with LLM, you can really automate those tech debt minimization tasks like maintenance and debugging, testing. And that's where we have focused within our company, and we have done a lot of work around that in last couple of months or so. So let's talk about debugging. So if you look into the traditional debugging, you will more or less you do this kind of workflow, right? You get a bug, and most of us like we do some kind of trial and error based fixed. And if it doesn't get resolved within time, we might ask our colleagues. We'll search online, maybe go to Google, maybe go to Stack Overflow and figure out the answer. So it essentially take like multiple trial and errors, and most of the time this process that doesn't scale. You have to repeat, rinse and repeat, and it's kind of one off for each bug, so it doesn't scale well. uh, as opposed to that, with LLM based debugging approach, if you have a good prompt and if you have selected a good enough LLM, then you get basically the resolution pretty quickly. And most of the time after some tuning, this process become a constant time process, meaning for a given bug, for some well tuned prompt and good LLM, you can get your answer pretty quickly. And that's really the promise of LLM. And essentially, like if your LLM is accurate enough and if you have a good prompt, your output is pretty much scales. I mean, you don't have to do one ops per bugs. It will just scale like in a constant time. So basically, that's paved the way to the this fact that you can really build a very high efficient, high quality code generation factory where you have a prompt and the context is basically nothing but a code, and then you have good code generation LLM, and then you have output. So how good is that? So now, based on that workflow, you can really scale and you can operate at multiple tasks. Basically, this code generation factory that can produce multiple product. The product here is a different software engineering task, maybe a refactoring, code review, and multiple others. And in the consumption side and the input output side, basically, so you can take your input in the code as in form of string, you can put it in a file, put it in form of some repo, and then output side you can get as a standalone string. You can, just a minute, sorry, you can get a script file, you can get JSON, you can get spreadsheet, whole host of output modalities you can get. And now this code generation, basically you can consume in different form. We have within our company, we have explored different ways. Like one is VS Code plugin, Docker image, different Python package, and also we have built some app internally, and we are verifying that quality of that app internally using some REST or gRPC API. So basically, it opens up different possibilities. And then we have stuck with open source LLM models, because open source LLM model provides better value in terms of data privacy. You don't have to send data to third party API like OpenAI or some other APIs. So basically, your data remains within your company, which is a very critical value for open source LLM. And another value is that it is pretty interpretable, meaning you have your own prompt, you have your own LLM, you can tune your LLM with different parameters. So basically, what is going into your code gen factory and what is coming out, you can quickly draw some mapping and figure out, maybe because of this parameter, your output quality is low. So you can tune them and you can get better output, which is not the case in some third party blind API, where you are just sending something and blindly waiting for it. And if it doesn't give you good result, you are basically toast. You don't know like how to improve. So that's a big value. And finally, the switching cost. So as you are if you are familiar about this space, you will see every week there are some new model, be it Mixtral, be it Phi, be it like new Llama 3. So every week almost there are some new models. So essentially, you should have more some flexible way of handling different models. I mean, you're trying out different models, and the newer model always gives better results. So you need to have a very flexible approach, and that these open source LLMs give you that switching ability. So then, as I was talking about this software code generation factory, it can give you different product. Basically, it solves different software engineering tasks. It can, but basically you can write code in different programming languages. You can write documentations for different programming languages. You can create template. So I have some of the examples about these use cases in constant of time and some internal code base. I can't disclose all of these use cases, but I would cover some of the very prominent use cases. So, and also before jumping into the use cases and few examples, I want to talk about the quality control aspect of our code generation factory. So our metrics here is something called average readiness. It is basically some form of accuracy. Essentially, 70% readiness means whatever being generated from our LLM, is it ready to be deployed in production or not? If it is, then the accuracy will be 100%, and if it is not, then it will be like lower, depending on how much edits you need to do before it get ready to be deployed. So 70% means that more or less you have to make one third of the code change, and this number we are improving, and it is also based on our internal quality standard. So this number is bit subjective, but overall this number shows that our model is good enough, and we are working on it to fine tune this accuracy number. And overall, we have tested about 200,000 lines of code, and we have generated more than 500,000 lines of code so far. So we have good coverage in terms of sheer volume of the tools, API calls we have made to our UI, to our code generation tool. So at this point, I'll be showing you some examples. Like I was showing you in this metric, right? Couple of cases. Like first one, I want to walk you through with the Bash coding. So Bash is a tool that we everyone use for our software engineering day-to-day job. So sometimes we want to understand few commands to, let's say, understand what are the latest file updates has been made. So what will be the command? I mean, many of us knows it, but sometimes we get forgotten about what is the exact command. So we have to pour over the documentation, the Stack Overflow, Google. So instead of that, you can call an LLM, and LLM, if it is good enough LLM, it will give you very high accuracy answer. So then I'll go into the Python programming language, which is very common. Most of us use in ML. So that with that programming language, I'll cover most of the tasks that I mentioned in the very first slide. So first one is a simple code completion task. So where you can prompt an LLM, write me a Tower of Hanoi game in Python. Basically, this is a very classic algorithmic challenge that most of us have solved in our college days. So it gives you a very detailed Python recursion based solution, and it also talks about what are the variables that it has used and tried to give you some semantic understanding of this code, which is absolutely great. And it basically promotes better ability to learn, and you become a better software engineering. It's not simple like code output. You basically understand what's going on, what are the semantic of the code, and also it gives you an example so that you clearly understand the code what it has produced. So the next use case I'll be talking about the code documentation. So it is a very important task to minimize your tech debt. So you have a code block in the left hand side of this table, and the right hand side it shows a documentation. So this is a Python function, and it is fairly complex, as you can see, with multiple clauses and different kind of conditionals. And it gives you a very thorough documentation, and it talks about what is the like input output, and then it explains you the semantic of that particular code, which is very critical. It doesn't stop at just giving you the syntax. It talks about the what is semantically happening in the code. So overall, you can claim the documentation quality is pretty high. Then next use case, I'll be talking about the code refactoring in Python. Again, you have a Python function. It's fairly, I mean, somewhat complex, not too complex, but somewhat complex. And then it gives you some refactoring idea to how to improve that code. And it essentially it has covered for this particular example, it has covered how can improve the readability and the maintainability of the code. As you can see, some of the ideas are pretty useful to improve your quality standard of your code base. Then I'll talk about unit test generation. Again, you have a Python function here on the left hand side, and it gives you a very thorough unit test based on the unit test library in Python. And good thing is that we have studied with multiple examples, and it almost covered good test coverages. It cover all the corner cases most of the time, like all the it gives you the guardrails for different possible failure scenarios, which is really good. And then the debugging is another activity I think most of us software engineering have to do. And basically it's so this particular example has some kind of scoping error, and it actually gives you the exact, I mean, accurate solution, and it also gives you idea like where it went wrong and what are the fixes you can do. So I absolutely love this commentary. Like it doesn't simply give you the solution, it also talks about what went wrong and how it has fixed it, which is really good for you to understand, like, and basically makes you a better software engineer. And finally, this is an up and coming use case. So basically, you have Python code, but some point you might want to convert it to some other language, maybe some new language coming up like Julia and few other. But this example is showing that we have Python code, we are converting it to C++, and then you are converting that to Rust. So basically, this gives you ability to move into different programming languages as new languages are coming almost every year or so. So that's a great ability to like pivot and improve your flexibility in your code. So I have just covered the Python languages, and similarly, you can cover C++, Go, Java, and multiple other languages. We have internally tested it, but in interest of time, next use case I want to walk you through is on template generation. So templates are basically nothing but some standard recipe for different software engineering machineries we use. So one of them is Kubernetes, that is widely used now. Almost everybody use it is for deployment and building the infrastructure layer. And this particular example, we are showing that, okay, can it write a Kubernetes manifest for a Go API? And as you can see, it has like gives you a very fairly good template. and maybe some of these attributes you might have to change depending on your use case and your particular scenario, but overall it has given you a very good template to start with. And also I love this fact that it gives you the idea of what went behind this template, so that you understand, and if you have some question you can further query LLM, or you can, if you like, you can do a Google search or something, and you can review it with your colleagues and peers maybe. And another good thing is that the generation time is pretty reasonably low, on little over half a minute, which is fairly acceptable. The next use case I'll be talking about little bit complex, where basically LLM is doing three tasks. It is fetching an summarization model from Hugging Face, which most of you know, it's an open source LLM repository. And then it is basically implementing, figuring out which model to use, and then building an Python API on top of that. So basically it is doing all these three tasks, and then also setting up proper parameters. So basically this is pretty impressive. You can just mention this kind of declarative statement and you can get entire application up and running, which is pretty impressive. And all these things you can generate within one minute, or 1 minute and 30 seconds or so, which is really great. Then SQL query generation is the third use case I want to cover. So basically, many of us has this kind of DBs, and we have to write some SQL queries, and you can simply write this declarative statement to the LLM bot, and then LLM will give you the idea like what will be the corresponding SQL query. So here example I'm showing, write a solution to find employees who have the highest salary in each of the department. It's pretty common, and you can map this kind of query to your specific examples. And as you can see, it gives you a very detailed, I mean, accurate SQL command, select and different joins, inner joint and group wise. And it also gives you like the reasoning why it has produced this answer. And all this is produced a little less than a minute, about 49 seconds. Finally, the last use case around template generation is the Jenkins setup. So CI/CD, whenever you do, most of us use Jenkins. So for a given Python API, it can give you a Jenkins pipeline code, which is again very useful, very handy to just get started. And maybe you have to make a couple of changes here and there depending on its specific use case. But to get started, keep the ball rolling, you can basically get started with this kind of approach. And again, the generation time is pretty low and you can move fast with this. So we have so far covered the most of the usability aspects of our code generation factory, or basically code gen tool. Now I'll quickly talk about the safety aspect of code generation. As you might know, generative AI is very useful, but it also generates token in a very probabilistic manner, and sometimes it can compromise your AI safety, so-called AI safety. So let's see what are the risk vector, or so-called like vector, I mean, safety threats you can have. So one of the safety threat is the toxic users. So somehow somebody maybe has a toxic intent and they can write some malicious prompt, and then your LLM weights and training data set on which your model has been trained, that might have some harmful data set which is risky to use. And then the ownership of your data, maybe you have a good LLM, but tomorrow somebody can come and they say, okay, you have trained this LLM based on our own data set, so you have to give us some royalty. So basically this is what going on between OpenAI and New York Times. So these three are the big risk, and to minimize that, there are some standard tools, and we have explored some of them. So basically, the Llama Guard is a big tool for handling this kind of risk, and we have explored that Llama Guard extensively. It's essentially we want to prevent toxic prompt and avoid surprises. So LlamaGuard is good for input output safeguarding, and there are some benchmarks like simple safety test and excess test. They are good for ensuring the prompt level safety and the LLM level safety guard. Basically, this is inside your model, and input output can be protected by LlamaGuard. So under the hood, we basically want to protect ourselves. Like there are two kind of prompts, like how to kill someone, which is obviously unsafe, and how to kill a VM, which is quite safe, right? Because this is some lingo we software engineers always use: kill the VM, kill some process. So this should not be blocked, but how to kill someone obviously should be blocked. So this kind of minute distinction, understanding that for that NamaGuard is really good, and there are many other fine-tuned models and tools that can be very useful. Okay, so the next piece is your data ownership risk. So as I was mentioning, this conflict between New York Times and OpenAI is could be very could be very applicable for any companies. So what are the ways we can claim the ownership of your data and make sure that we are not violating any infringement? So there are some very standard tool like scan code where you can figure out the lineage of the training data set that has been used, and if there is some data set that is not permissible and that might be infringing some licensing code, maybe we can stop our generation process there. And then there are some tool like black ducks and other to improve your data security as well. Finally, another piece it is really up and coming in the LLM world is called this kind of plagiarism tracing. Basically, there are some malicious actor who want to kind of hit some glory by building some model, but some of these models are simply copying the code from some code base, right? So this is a basically a screenshot from Hugging Face space, and they have this model named Star Coder 2, and they have come up with this app named Dataset Search, where you can simply put your output generated from your LLM and then figure out whether this code is basically have some replica from some training data set or not. For a simple one-liner declaration, it is okay. Is some simple if else statement that might be still okay. But if you see your entire generated class of your Python function, if it is copied from some particular code base, that is probably a risky thing. So this tool is becoming very handy now. So that's another thing we have used internally. So once a risk is done, I want to just cover a little bit about agents. So agents are basically a very high-powered way of like communicating with your LLM. And LLM, even if a small LLM can outperform a big LLM if you have a good prompt, good fine-tuning practices in place. So embrace agents are basically becoming the superpower, and we want to cover that. And we have extensively done. We are working on it very extensively within our team. So basically, agents, you can think about it's your master machine within your code generation factory. Essentially, agents distinguish between the different nuances of LLM, how LLM thinks, how LLM reason, and how it process your information. So LLM try to influence, I mean, agents try to influence all of these threads. So one thread is basically how to plan the task. Let's say you ask LLM, write me the code for Fibonacci number. So what are the steps? Do you want to command LLM to produce in a iterative manner, or do you want to make it a recursive manner? All those things, fine grained control you can basically exert by writing a good planning script. Similarly, how it will execute, that is again something you can write in a very declarative way and LLM will follow it. And then critic, basically you can set some guardrail that okay, whatever solution you produce that might be maybe running in some polynomial time, it should not be exploding in space, and all those constraints you can give in this kind of critique. So let me give you an example that to make things little clear. So yeah, before showing the example, I also want to give you this specific unit test generation for at a file level. So unit test generation at a string level is fairly easy, but can you pass an entire file and generate unit test script for a single shot? That's a work we are extensively doing internally. And you so these are the workflow. Like first you give a file, and then AST, basically abstract syntax tree, where you're extracting all the components of a file. Let's say what are the functions here, what are the classes, what are the methods out there. And then for each of those components, you write the unit test. And then finally, you combine all the unit tests to put together a single script. And that's why it's kind of like a map reduce operations, but very similar, but not exactly same. It is completely governed by LLM, and to enable this kind of workflow, we have used this prompt. So basically, as you can see, this prompt gives you very detailed planning and the execution steps, and LLM is following that. So really, prompt engineering, you can think about it's a master machine or kind of connecting tissues between your different code chain activity, and you can exert very fine-grained control on your LLM with this kind of prompt. Okay, in this section, I'll be talking about the LLM serving, which is a critical challenge. And before going to the challenge, I just want to do the recap that LLM is basically, again, this is kind of a code gen factory, and the ingredient to the factory is your prompt and the context, and LLM is the real mechanism that's your machine, and then you're getting some output. And here basically when you talk about the prompt, and this is the top piece is basically the prompt where you are giving some instruction to your LLM that okay, give me whatever, whenever you are giving some command, you follow this step. And the context is basically a specific code block you are giving. Like let's say you want to write an unit test for a Python code, and the context is where you are passing that code. And then after once the prompt and context are done, they are kind of combined with something called prompt template that I was showing in the last screenshot. And then that prompt template, I mean, together with your specific context, become your input to your LLM. And then LLM does some sequential generation. Basically, you generate one token at a time, and that is little bit difficult to handle, especially for the resource utilization standpoint. And before going into the resource part, I just want to talk about the prompt piece, which is the top layer of this diagram. That prompt and the basically that prompt and context. So the prompt is basically for the code generation piece. Here this is your very standard stuff. It is we call it prefix also. And this is like invariant across all the request, where whatever request come, you just want to use this prompt for the given task. And this is a prefix or a prompt for this unit test generation, where we are just telling that if whenever the context will come, you follow this step. Like you have a file where you have to write multiple unit tests, and then you follow this instruction like remove any repeated import statement, combine, define any, all sorts of nitty gritties of the of your unit test generation activity that you can control. And then the final piece is the user prompt, which is the variable across different requests you have at your hand. So that's where you will pass your code block. Maybe you want to write a unit test, and this will be the file what on which you want to write the unit test on. So now coming back to that resource piece, so I was mentioning the LLM produce one token at a time. Basically, the generation process is something called auto-regressive, and that is basically coming from the transformer mechanism. And also another property of this thing is that it's just quadratic time in terms of the input length due to this multiplication, the softmax, as you can see, this query and key that they get like inner product, and that inner product is basically quadratic in the sequence length. And that is actually a major bottleneck when it talks about the memory utilization for your GPUs. And that is a big challenge, and there are many various solutions we have explored to handle this. And this is an example like how the token by token generation is taking place. And this is some natural language example. I mean, due to like constraint, I have not put any coding example, but you can very well understand. Like let's say you just put these two input, I think and I love. So I think has, let's say it has generated three tokens, and I love generated only one token. I love LLM and I think this is great. So this LLM will be produced at one shot, and then this block will be like I love LLM is getting will get stopped because it's the end of sentence is reached. But the first thread will be continuing, like then there are two more tokens will be generated, is and great. So overall there is this imbalance in the response, and then how to manage the queue and how to handle this kind of imbalance, and the concurrent scenario where you are handling multiple requests in a single second, there this thing could be very challenging. And for that there are multiple solutions in there, and one of the things that people have done is called kv caching. So kv caching, k stands for key and v stands for value. So where you are caching some of your like immediate vicinity context so that you can call them when you are generating a token, and that will improve your generation time, which is something was originally done and like 2 3 years back when this thing have come out, the generation mechanism. But the kb caching has its own challenge. Whenever you are producing new content, it has, traditionally due to our way the memory has been architected, you just stored in a contiguous location, and then you have to reallocate them because you are just generating like one token at a time. And that kind of relocation, I mean allocation and deallocation, put a lot of fragmentation on your memory, and overall utilization really gets low. So this chart here, as you can see, the first chart, it is basically the old solution. Some people used to use orca back in 2021 timeframe. you can see that the large part of is wasted because of the internal fragmentation. And currently there is a state of that solution that most of the modern teams are using, that's called VLLM. So VLLM handles this fragmentation issue, and that actually solved this thing. And VLLM is something we are using in our team as well, and it is one of the best solution out there to handle this fragmentation issue. So at this point, I would love to show you a very small demo. And basically, as I mentioned, that your code generation can be consumed in different shapes and form. It can be a REST API, it can be a VS Code plugin, it can be an agent-based workflow. So I'll start with this VS Code, the VS Code plugin, which is a very popular choice of this code consumption. I know that the GitHub Copilot also use some kind of ID plugin. So we have been inspired by that approach, and our first tool was the VS Code plugin. So I want to show you that. Um, Pritham, I should share my screen, share screen, right? Right here.
Correct. You'll find that option below.
Okay, great. Let me just share my screen. Okay, let me open the video. Meanwhile, if anyone have any question, I'll be happy to answer as I am opening the video.
We do have two questions, Rajat.
Yeah, maybe I can answer them. Yeah,
Yeah, I
maybe.
will narrate it for you. So, first one is from Ilona Brimmeyer. She's from Dataport,
Mhm.
and she asks regarding the code quality. Have you validated the architecture as well? Means design pattern usage from software engineering. How good is that topic realized?
You mean the architecture of what? Is it like a specific software, like how, I mean, architecture of the LLM itself, or how we are doing the prompt, or what is the what?
So, Ilona, if you can, elaborate on that question, it would be great. But so far, this is what we have. Regarding the code quality, have you validated the architecture as well? Means design pattern usage from software engineering.
Yeah, so
How good is
basically,
the
we have an internal users who have been testing this tool, and we have a community of about 150 users within the company, and they have used multiple artifacts of these tools we have produced. And I think when you talk about the pattern, the LLM is kind of like a black box. We have some parameter we can tune, but I think the bigger piece is that prompt and how we are and prompt and the prompt template, how we are passing that combined input to the LLM, and then the VLLM and other tools which are very important for serving piece, because your concurrent request you have to handle, right? So you can't get choked, and that's where the serving piece get very critical. And then another decision you probably have to make, whether you want to fine tune or not fine tune, whether you want to use RAG based approach or not. So those data decisions you have to make. So I can go into any specific if you have any question. I mean, otherwise it's very difficult to comment in a generic manner.
she says that it's she means from the software result.
Software result.
Uh, yes, Ilona says I mean the software result. So that's what she wants answer for.
So software result, is it, does it mean that how we are benchmarking the accuracy of our LLM's output, the accuracy? So that is based on user feedback, because there are some standard metric like blah and others, but that doesn't work very well. But yeah, it's predominantly based on human eval at this point.
I hope Rajat has answered your question, Ilona. But you can we can elaborate on that. If you can drop an email regarding this. So another question is from Diane Marsili. She's from SNIA US. She asks, performance is a major challenge in using Open LLM.
Yeah.
What infrastructure you are using to run LLM models, and how have you done any fine tuning on the model before using it? Which Open LLM model was used for Kubernetes template generation? So that's
Okay.
the question.
Yeah, that's a very good question, and probably I have missed that which model we have used. So we have explored different models, and so far our choice is basically the tie between Star Coder's V15B. and that's a version 2, start coder version 2, 15b version. I mean the parameter version. And also we are extensively using this code llama 13b instruct. And then there are different other models, like apparently code llama, I mean llama 3, that is working well for code data as well. Mixtral is another good model. So we have different choices. And then infrastructure standpoint, yeah, obviously that's a major pain, and we are still in kind of very proof of concept phase. So we didn't get like really big high power GPU yet, but we have fair number of GPUs at least to get started, and we are that working out reasonably well. But to scale things up, we definitely need more GPUs. But yeah, I think that's what I would say.
Thanks, Rajat. Any more questions from the audience? I think Rajat, you can share your screen if you're
Yeah,
ready.
yeah. So let me just turn on the video. Yep. Can you see my video? No, right? Okay, let me just share screen. Uh,
You can try now. Well,
Yeah, I'm trying entire screen. Okay, can you see my screen? My video? Pritham, can you see my screen? Video?
not yet, not yet.
Interesting. I need to share entire screen. I'm sharing entire screen. Now, can you see my screen?
Not yet. So below in the beside the plain video option, you can see that there's a share screen option.
Yeah, that's what I'm trying to use, but it seems like it's not working. I'm curious what's going on. So I'm choosing entire screen because I want to share a video offline window maybe. Okay. Now can you see a QuickTime video player? MP4 video?
Not yet, not yet, Rajat. Not sure.
Um, can I don't know how to handle it. Can I pass this video to you and you play it? Is it possible, or
Sure, sure. You can do that.
how should I email you or?
You can email me.
Just a minute, I'm doing emailing you. Yeah, I just sent a video, Pritham.
Until I open my video, Rajat, you can actually answer Ilona's question. So she's made it clear of the question. I hope you can see the question on the
No,
questions box.
okay, question. Okay. Sorry, I not being specific to my question. In former code result 1 year ago from LLM coding, I saw that the resulting software had a bad design architecture compared to approach, having discussed the feature design for use cases that should be implemented at the beginning of software architect. I guess because of using bad prompting. So, how often have you worked on prompting being satisfied with the code quality created automatically by LLM? Yeah, so great question, Ilona. So prompting is something we work very often, and frankly, that's the big differentiation between like good quality result, because the model is more or less fixed, but prompting really is a big difference. So the architecture piece and all those things are again pretty standardized by now. The bigger piece is the prompting, or how well you have fine-tuned your model, how good is your data, all those things actually. Another piece is that prompting is one, and then prompt template that you use to combine your context and your this thing prompt, or basically instruction to your LLM. That's very critical. Okay, yeah, there it is. So you can play the screen. It is little initially
Yeah,
they dark, and then maybe you can maybe forward it to like 10 second, and then it will be showing you some screen.
yeah, you can see the screen,
Yeah,
right?
yeah, yeah. So can you pause here? I just want to set the stage.
Yes.
So basically, this is a VS Code plugin that we have built with our API, and there are two features to it. One is inline filling, and another is your chat feature. So right now, what you are saying is inline filling. So we are selecting a particular code block, and then I'll be asking what is this code doing and explain this code. So this is something like a documentation or code interpretation use case. And then left hand side is the chat feature, but that one I'll be showing after this. Can you just run it again, Pritam?
Yeah.
So you'll see it will. Yeah, I'm writing on the top that okay, what does it do? Yeah, it has like little delay, but it will be there very soon. Yeah, as you see that it has produced like what is this function, what is the name, what are the variables it has used, what are the outputs, and all sorts of details. Right. So now I'm moving to the chat feature. Chat feature, I'm asking LLM to write me the C++ code to solve the some like to some problem, right? So that actually no, that is solve the tower Hanoi puzzle. So write me a C++ code to solve the tower Hanoi puzzle. So it will again like take a couple of seconds, and then it will write you a C++ code, and it will explain like what went behind the code, both semantic and syntax. Now it will ask like now I'm asking that what is the complexity of this solution, computational complexity of the solution. So it will be giving you the idea like what is the computational time. Again, little bit of delay, but it's fairly fast. So it has, as you can see, the solution is exponential time, which is really bad. So we can further investigate and ask LLM to give us a linear time solution, and that's what I'm doing. Can you solve it in a linear time? So it is a purely chat based feature. So it has context and it knows like what I meant by it, and it gives you the complete solution using a hash map, which is significantly faster than our iterative solution. Now I'll be asking it to write me a unit test. Yeah, so it gives you some unit test. So yeah, I think that's all what our plugin does, and we are testing it out internally with different code base with different use cases, and we are fairly getting good, reasonable accuracy. Of course, we have to improve. We are constantly tuning, setting up infra for bigger models and stuff. Can we train VLM using any of our in-house custom library? If yes, any reference? So Satish, what do you mean by custom library? VLLM is like a more of a serving tool than it is a model. So it's like based on page retention. So I'm not sure what do you mean by custom library here. You can elaborate if you can. Hi
Uh,
Pritham.
yes, yes. So we've actually come towards the end of the presentation. So I would request the audience to drop all queries they have on this webinar.
Yeah, I'm trying to respond to Satish's question. So Satish,
Yes, yes.
so I'm just curious what he meant by custom library.
Satish Iparangi from Samsung Electronics. Can you please elaborate on this question so that Rajat can answer it? Satish has come back. So he says in-house developed Python libraries and tools.
Ah, okay. I mean, then that means you have to replace VLLM with that. I mean, I am not very familiar with any solution which work as good as VLLM. There are people are building some tool based on the VLLM, some wrapper on top of VLLM. One tool is that Hugging Face as TGI. TGI might be an effective tool. So yeah, that would
Yeah,
be.
we have Mosmi Rana Singh as well from Nutanix. She's a staff engineer there. Mosmi, would you like to add on to this presentation?
I had a demo to present. Hi
Can,
everyone, can you all hear me?
can you send the
Ye-
demo to Prism probably because the our screen sharing option seems like not working.
Yeah.
Just email to that thread.
Can I try screen sharing because it seems like very big, so I'm unable to.
Yeah, you can try. Sure. Go ahead.
No, I'm unable to share. Yeah, I can take up any questions, but it is something similar to whatever Rajat was showing.
Yes, Mosami. On the right hand side, you can see the questions tab. Over there, you can actually answer to the questions that have been placed.
Right now, there is no active question, I guess.
Yes.
Okay.
We can keep the window open for 2 more minutes and probably close it here. Rajat?
Yeah, sure.
Okay.
Sounds good.
Rajat, Mosami, we have one question from Vinayak Krishnamurthy. He's from Agilad Technologies Private Limited. He asked, how much of the code generated by LLMs have you guys put in production?
So we have not done any production deployment as yet. It's still in the validation phase. We are going through some legal review and few other like red tapes items. And once that is done, we should be ready for the production deployment. Do you have any follow-up, Vinay? Anything specific you want to ask?
I think that's all from the audience. Uh, Thank you,
Okay.
Rajat Mosimi, for presenting a wonderful presentation. And we would like to see you all on the next one. And have a good day. Yes, I think I'll be closing this. Rajat, we
Yeah,
good?
good, good.
Okay.
Thank you, guys. Thank you. Bye.
Thank you.
Thank you, everyone.